So what we're going to talk about this evening is electronic conspicuity systems and gliding, which is a nice complicated subject, but I'll try and make it reasonably straightforward. If anybody's struggling to hear me, because I'm not coming through well, do flag that up in the chat as well. This is the agenda. I'm going to talk about why we need electronic conspicuity. A bit about the technologies, not in too much depth, but enough, hopefully, to understand some of the later things that we're going to talk about. A bit about the regulations, because they're important here. The politics, quite a big issue in this topic. And then some discussion, view about where it's all going, and perhaps the important question for this group, what is a glider pilot to do with all this? So let's start on why we need it. I guess the primary reason is air proxies, not hitting people. And those are increasing. And this chart is up to about 2015. But you can generally see a growth in air proxies. And if we look at drones, they're becoming quite a big issue. And that is one of the big drivers for electronic conspicuity in the future. And one of the things that makes the industry try and do more in electronic conspicuity, and the CAA do it as well. And you'll see a whole number of operations at the moment putting in temporary danger areas to fly drones beyond the line of sight. And electronic conspicuity is quite a big deal for trying to share the airspace with things like that. But what about gliders? Well, the primary threat to gliders is actually other gliders. It's not drones, it's not powered airplanes. Powered aircraft typically collide with other powered aircraft, and gliders typically collide with gliders. And if you look at the statistics over the past 43 years, we've had something like only about 7 glider power collisions, 3 people flying over the launch site, and only 4 out in the wild countryside. Excuse me. There have been 7 glider tug collisions and 94 glider collisions. So when we think about electronic conspicuity and collision avoidance, really by 9 to 1, we need to worry about other gliders. And those collisions are very strongly related to the density of traffic. So most of them, 4/5 of them, happen near the launch site, and only 20% cross country. Collisions with other GA, it's low percentage of accidents and something like 6% of the fatalities. So the message from this slide is very much worry about hitting other gliders, and worry about hitting other gliders near gliding clubs. And that's particularly true of areas where there's a high gliding density. And this is actually a plot generated from the BGA ladder. So it's not all glider flights, it's glider flights that have been put onto the ladder. But you can see quite easily the big glider motor, the clubs and the big glider motorways, particularly in the south, but some peaky bits up in Scotland and in the middle of the country as well. But this area around here from Parham and Lasham up and round past Dunstable, Husbos, Cambridge, that's very much the high density traffic area for gliders. And there's a lot of power traffic going around there as well. Okay, no problem, we can just look out. But look out is rather less effective than we would like. Its effectiveness decreases as closing speed increases. So the faster something is, the less we're likely to see it. And as traffic density increases, so as there are more aeroplanes around. We don't spend enough time scanning, looking out, and we're actually, the big problem is we're bad at seeing things. Empty field myopia is the situation where when you look out at a blue sky, what you end up doing is focusing about 2 meters ahead of you. So anything that's not 2 meters ahead of you is out of focus. And the limited visual acuity means that we only see the bit that's a few degrees around where we're looking, and the rest of the sky we have much less resolution on. Additional cues can help, but can distract from other traffic. So even if we're told about something, we might focus on that and not on something that's about to hit us. But the bottom line of this is that if you fly with electronic conspicuity and that tells you where traffic is, quite often you can't see it, even though you know it's there. And indeed, when people have done formal trials on this, pilots have only seen some 50% of near collision contacts. I reckon I'm quite good at looking out. I can sit in two-seaters and have competitions with the guy in the other seat, and I win my fair share. But I'm just amazed at how much stuff I don't see. And the big problem is the stuff you do see tends to be the stuff that's not going to hit you. It's the thing that's moving in your field of view. The one that's going to hit you isn't moving in your field of view. So if we're worried about mid-air collisions, then lookout is not a great solution to the problem. And actually what we're relying on most of the time is that this is a big sky, and gliders in particular don't fly at particular common levels. So mostly we miss people. What about other visual technologies? Well, they're largely ineffective. Some of us put orange stripes on our gliders, but actually the evidence is that mostly that just works as camouflage. It breaks up what is otherwise a single outline. And there's a possible exception to that, which is it's worth having orange on a glider when you've got a white glider against a white snowy background. So if you fly down in the Alps, it's compulsory to fly with orange stripes, and you can make that case. But in the environment we fly in the UK, putting orange stripes on is not effective. The RAF did quite a big study on that, flying motor gliders at each other with various forms of orange stripes and the like, and they couldn't demonstrate any value to it at all. Some people put strobes on their airplanes, on their gliders, but with the sort of power outputs that we can achieve by battery-driven strobes, they don't really work either theoretically or practically. If you do the sums on how much light you get out of them, it's actually only a very small fraction of daylight. And certainly my experience when flying with other people who've got strobes on, the sequence goes something like, you know there's an airplane out there with strobes on, you look on Flam, find the airplane, find the glider. Once you've found the glider, you can see the strobes. They're not a practical way of really drawing your attention to the glider. If you're looking at it in the right place, it's fine, but you're not going to find it. Okay, so that's why we need it. So what have we got in the way of technologies? And here we've really got a cornucopia of delights. There's a lot of them. We can use primary radar, transponders, secondary radar, and traffic collision avoidance systems, Flam, pilot aware, and various forms of Adsb. Those are the obvious ones that are available to us as glider pilots. So let's have a little run through those and try and understand what they do and how we might use them. But first of all, I want to make some distinctions which are going to be important later on. I want to distinguish between traffic awareness. So that is some sort of system that tells us about other traffic, either visually or orally. So that there is an aircraft 10 o'clock at 2 miles at our level, or a display that plots that. There's collision detection, something that says something is about to hit you. So Flam does that. Everybody who flies with Flam knows about the flashing lights and the loud sounds when somebody gets too close. And then there's collision avoidance, something that says something's about to hit you, turn right, or descend or climb or whatever it is. And in general, the systems that we have in gliders do one of the first two of those things, and they don't do the third. Airliners fly with the third. That's what TCAS is, and it will give a mandatory do something about this impending collision. But it's expensive, and we don't have it in gliders. But importantly, so the important distinction for us is that between traffic awareness and collision detection. We'll come back to that. Okay, primary radar then, and secondary radar. Primary radar, pretty simple. There's a radar somewhere, it emits radio energy. Some of that bounces back off the whatever's in the way, and it plots the position of that. So it knows where it was pointing when it sent the blip, and by the time of flight, it can work out how far it was away. So we have these little smudges on a screen, and they're the returns from a primary radar. And often, if we're flying around and we don't have a transponder, and we're talking to particularly a military radar service, they might see us on their primary radar, but they will tend to filter out slow-moving contacts so that they can filter out things like rain. So often a slow-moving or circling glider is just going to disappear from their screen. Secondary radar, though, is what is the other end of a transponder, and what happens there is there's a little box in the airplane or the glider which we can set a code up on, and when that's interrogated by the radar, it sends back some information: the height of the aircraft, the call sign, possibly one or two other things. And on the radar controller's screen, you get something like this. So here we've got, this is a code. This is EasyJet 391, and it's the height, it's going up, how fast it's going up, and so on. So this is typically how commercial air traffic is looked after with secondary radar. In a glider, we can put a transponder. In mine, I've got one of these. It's a Trig TT22. It's a Mode S transponder, which is what you would buy now should you buy one. Quite high power, 250 watts. Remember that number. And we'll compare it with some of the other things we're going to be talking about soon. It has support for, we'll come to this, but Adsb. So this can emit Adsb as well as do the transponder job. But it costs pretty much a couple of K. There's a lower power version which is a couple of hundred cheaper, so that's the 1800, which would be fine for gliding. What it does is it helps air traffic control see you. So if that's a thing that you need, this is really the only way you're going to do it. The reason I put one in my glider was I fly around Mildenhall and Lakenheath quite a lot, and you've got a lot of fast-moving jets and some big tankers and things which are in Class G, and it struck me as quite useful that the controllers controlling them could see where I was. So they stay out of my way, basically. It's not much good at helping most other aircraft see you. Anything with a TCAS, a system that will see transponders, will see you, but that's really that's an expensive system, so it only goes in bigger airplanes, which we don't tend to share airspace with. That's transponder. Come to Flam. And many of you will have seen these pictures before. So most cross-country gliders in the UK, I think, carry Flam. I would estimate above 80%, maybe even 90%. Typically, gliders, sometimes clubs where gliders stay more locally don't carry Flam, particularly the smaller clubs. I think at Cambridge, pretty much every glider we have has Flam in it. And here we can see, I'll come to that. So this is a short range system. And we're talking about a small number of kilometers for its range, air to air. But it does do collision detection. So it will alert if it thinks something is going to hit us, and that's very good. It's optimized for gliders. So it won't alert when, even though we're close to somebody, if we're not in danger of hitting them. There are something like a couple of thousand units, I think, in the UK of that order. But it's carried by very little other GA aeroplanes, general aviation aeroplanes. The Air Force have got it in a few of theirs, their tutors and one or two others. It's in the Battle of Britain Memorial Flight, for example. But Flam haven't successfully managed to penetrate any of the broader GA markets in this country. It's a different story in parts of Europe, but not in this country. On this picture, you can also see, so on the left, the big picture in the middle, which is a 9070. Here we can see a lot of contact on the screen, and that's traffic awareness, really. That tells us where other airplanes are. It can be useful if you're soaring and you want to know what other people are doing, if you've got the range on your system. But it's not delivering the primary purpose of collision detection. On the bottom right here, we've got a little Flam traffic display, which has much the same picture, but no map, just the aircraft. And the top right screen is a little Flam display, which gives you just the alarms. So in this case, we've got an alarm of something coming from our left wing, just behind our left wing maybe, and a little above us, and a kilometre and a half away. And putting one of those little displays right in your line of sight can be quite useful. Let's talk a little bit about how Flam works. It uses what's called a license-free industrial, scientific, and medical radio band. This is at 868 megahertz, and it's not that it's regulation-free. There's plenty of regulations associated with it. You have to use it in a certain way. What you don't need to do is get a license to use it. So anybody can build a system that uses this band, and there's no protection against people doing that, other than they're meant to obey the rules of not emitting too much power or taking too much time in the band, so that other things can operate around it. In Flam's case, they send an encrypted packet, but the encryption is known by other people. So it has been broken and is used for things like the Open Glider Network, which is the glider tracking system that many of us use. And what this little box does is it transmits where it will be in a short period of time. And it listens for other Flams doing the same thing. And if the two Flams consider they're going to be in the same place in a small number of seconds, then you will get an alarm. The performance of the box is very dependent on the way it's installed, though. The problem with gliders is that we're reluctant to stick antennas on the outside of the glider. Those of us with transponders tend to have a little antenna on the outside of the glider, but it'll be the only one. So mostly we put the antennas up just in front of the pilot on the coaming somewhere. And particularly for anybody with a glass fiber glider, with a carbon glider, carbon radio opaque. So if you imagine the Flam antenna being a little light flashing, anywhere where you're trying to look at it through that radio opaque carbon is not going to work very well. So the directional coverage tends to be fairly poor. And if you've ever flown, for example, directly behind, close to, behind and underneath somebody, chances are your Flam won't be seeing their Flam, which is sitting in the cockpit ahead of the pilot. So somewhat limited, but not too bad head on, and definitely better than nothing. I mentioned OGN, so one of the things that we've built over the past, I don't know, 7 or 8 years, is the OGN glider tracking network, and that's getting quite extensive use. Ooh, it's more than 5 years old, I think. I think this slide's probably a couple of years old. Something like 800 receivers worldwide. It's probably more than that now, and certainly more than 130 receivers in the UK now. But pretty successful. And we'll come to that. And this is broadly how it works. We have gliders and other things with Flam in them. We have a set of receivers on the ground. They decode the Flam signals, send them to a couple of servers, and then other systems can interrogate those servers and display the positions of the gliders on a map. And that's all been rolled out by largely by volunteers, in fact, all by volunteers, I think, and is a pretty low cost and successful infrastructure. And we'll come to how that's useful for this topic in a moment. All right, so that's the glider thing. A bunch of people developed something called Pilot Aware. And although this is more of a commercial product than the OGN stuff, more like Flam, the team that were doing this were mostly retired people doing it for fun and because they thought it was a good thing. So this is a traffic awareness system designed for GA aeroplanes. It's pretty similar to Flam in its basic operation, in that it sends its position and receives position from similar things, and then passes that information to the pilot. A significant difference is the way it does traffic awareness and collision detection. So unlike Flam, which will both give you traffic awareness and collision detection, this will really only give you traffic awareness. And it tends to pass its data to a product like SkyDemon, which is the equivalent of our LX moving maps, for example, or CU or LK8000 or whatever. And the collision detection is done on that product. This also receives Adsb and transponder signals. We'll talk about the Adsb in a moment. Pretty low cost. Current cost is about £325 for this, which is a thing called a Pilot Aware Rosetta. And they had about 2,600 sales as of 2019. They've been selling pretty well ever since, but I don't have up-to-date numbers. And as I say, that display is via something like SkyDemon or your phone or an iPad or something of that nature. What's interesting about this is that this team, after there was a junior that was hit by a GA aircraft somewhere near Husbos a few years ago, and that triggered an interaction between the Pilot Aware team and the OGN team, so that what they did was extend the functionality of the OGN receivers on the ground to include the reception and transmission of Pilot Aware protocols. And now what happens if we have one of these things is gliders can be received, and then their positions can be transmitted back up to aeroplanes that are flying with pilot aware. So we've put quite a lot of effort into getting those things at gliding clubs, and that's been pretty successful. And what it means is that we have some protection against GA aircraft coming past gliding clubs, because they will be able to see our flams when it is retransmitted via this mechanism. And as an example of that, there we go. Here's a picture of somebody passing Gransden Lodge. This is a microlight that came out of Eversden to our southwest. And here's a screenshot from him. And you can see up here at Gransden Lodge a K-21 in the circuit and also a glider on the ground. So this is the sort of picture that would appear on the Sky Demon that the powered airplane is carrying. And I think this is a very useful thing for us in the gliding world. You might have seen there was I think it was publicized by the BGA the other day. The pilot aware guys have offered any gliding clubs the opportunity. They will subsidize one of these receivers at our sites if we don't have one, or if it's just an OGM, they'll basically do the upgrade for free. So I would recommend any club that doesn't have one to have one of to get one, and there's money available to make it very inexpensive. By very inexpensive, I mean or £100, something like that, which seems pretty reasonable. Let me just pause for a moment and take a look at the questions and comments that have come up, so that I can address anyone. Okay, let's see. Okay. Okay, there's some comments there which you can read. Phil said quite a lot of aircraft operating in Class G have power flam now, e.g. Cranfield's Jetstream. I'm not sure about the word quite a lot there, Phil. I think it's relatively few compared with the number. John asks, is that 2,600 in the UK or globally for pilot aware? I think at the time that was most of pilot aware is UK, so it's pretty much UK. They're moving out into Europe, but haven't got that far yet. Does anybody know more than is on their website about the new Rosetta FX in integrating pilot aware with Flam? Yes, I do, and I'm going to tell you about it in a minute. So we'll do that. And TCAS is traffic collision avoidance service or something like that. Right. Okay. So we've just talked a little bit about rebroadcasting Flam up to pilot aware, but the other thing they're doing is, just out of interest, is they are also rebroadcasting other airplanes with transponders. So the problem with transponders is that they don't actually broadcast their position. They require that secondary radar to work out where they are. But there is a service called 360 Radar, who have what are called multilaterated receivers. So they have a lot of receivers around held by hobbyists, and what that does is measure essentially the time of flight from a signal from a transponder, and by doing the sums appropriately can work out where it is, and that passes that information over to the OGNR station and broadcasts it back up. So now we have a system that is rebroadcasting Flam aircraft, Adsb aircraft, and people with transponders. So that's quite useful. And this is broadly how it works. So the little airplane flying around, it detects the transponder signal from another airplane, and then it gets told where that airplane is. I think this is quite an interesting set of developments, and the pilot aware people are putting a lot of effort into the ground and the network side of this. And one of the things it gives is this thing called the ATOM grid, which is air traffic operations management, I think. And that might be useful to us because what it does is provide quite a good view of pretty much any aeroplane in the local vicinity that's emitting anything. So if we have one of these OGNR receivers at our gliding club, we can have that display, which could be useful if you're worrying about powered airplane breaking through your winch circuit. You might get a view of what's around before it gets there. A few other things that's getting transmitted on that includes weather as well. And yeah, that's pretty much it. I think I've covered everything there. So happy to provide more information about that, such as I know it, if anybody wants that. So this is John asked about the new Rosetta FX. This is the new Rosetta FX, which is much more aimed at gliders. It's pretty much a pilot aware with the ability to take information from a FLAM and then pass it back to a FLAM. I've had the equivalent in my glider for a couple of years, except I built it from scratch. And what it allows you to do is insert the pilot, take the FLAM traffic out of your FLAM, add the other traffic that this thing can detect, and then pass it to your traffic displays. So that, in principle, gives you the ability to transmit and receive pilot aware, get Adsb in from other people's Adsb transponders, get mode S from transponders, and FLAM that's read broadcast. But there's two quite big issues with this in terms of the use in a glider. One is it doesn't have alarm generation. So the thing I found in my glider is if I'm flying along and somebody with a FLAM is a collision threat, I will get the alarms. If somebody comes along in a PA-28 broadcasting one of these other things, unless I've got my traffic displays in my scan pretty regularly, I won't know about that person. And even if he's going to hit me, I still won't know about him unless I can spot him on the display. So it's only a partial solution. And then the other problem with it is the thing about antennas. The rebroadcast from the ground really only works well if you've got an external antenna. If you've got a little antenna in the front of your cockpit, it works much less well. So you only occasionally, or part of the time at any rate, even with a local transmitter, get that information. So it can be quite useful. Sometimes I get told about FLAM contacts 20 kilometers away, but there's no guarantee that that is going to happen. Okay, so turning to Adsb, I've mentioned that a lot of times. What is this thing? Well, it's a bit like the other two technologies we've been talking about, FLAM and pilot aware, in that it transmits its position and other airplanes detect that and can decide what to do with that information. This, though, is a licensed frequency. It's up at 1090 megahertz, and nobody else can use that frequency band. You'll come across the phrase extended squitter, and what that means is if you use your transponder, the transponder can add on to its transmission the Adsb part of it. So if you've got a trig transponder, the sort that I described earlier, you can at pretty much no extra cost have Adsb out. It's high power. Even the lower end is 40 to 80 watts, and it can be more than that. Actually, this isn't entirely true. It requires a GPS. Actually, they've changed the rules now, and you can put an uncertified GPS into it. So you can connect it up to your FLAM GPS or your LX9070 GPS, whatever. and make use of that. There's an issue about what quality of signal is being used. So in essence, there are really two Adsb systems. There's the commercial one that uses very high levels of system integrity, and there's the more GA one, which don't use that level. And the commercial one won't necessarily see airplanes that are transmitting to the lower cost GA standard. It's pretty old technology. It's really an extension of the transponder, and it's been around for decades. So it doesn't get the technical performance of some of the newer things that we're talking about. Maybe the resolution is a bit limited, but it's where the CAA are putting their money. So it's required for large IFR, instrument flight rules, and general air transport aircraft in Europe from 2020. So all your airliners will be flying around with that, and they can combine it with TCAS to make TCAS better. So it gives them a bit more information. What it doesn't do, though, is do anything for giving you visibility by air traffic control. Almost nothing. There've been one or two trials, which I'll mention in a moment, unlike in the USA, unless you're doing oil rigs in Aberdeen. They are, though, looking at a second frequency and have done trials of weather services on that second frequency, and probably that frequency will get used for drones and possibly traffic rebroadcasts. So things are happening in this space, but fairly slowly. As an extension of that, there's been the development of something called the low-powered Adsb transponder, or CAP 1391, which was the CAA document which described it. And this was defined a few years ago, and the intention was to try and provide a low-cost Adsb beacon that people could put in airplanes. So portable, lightweight, low bulk, easy to use, easy antenna fit, didn't have to have it interoperable with other things, with alerts, aim of 250 quid, put it in the cockpit and make it pretty much self-contained. So quite an interesting idea, and it happened. So many of you will have heard of Sky Echo, and that is exactly one of those. It's this is the UAvionics Sky Echo 2, which is Adsb in and out. It has the possibility of either doing Flam or weather reception. It's got a second radio in here and a second antenna, and at least in theory it can pick up Flam. It needs SkyDemon to decode that Flam, but at least in theory it can pick up Flam. I'm a little worried about the antenna. It would suffer from the same issues as our gliding antennas do for Flam reception, only this one's probably a bit worse. Again, it's giving you traffic awareness, maybe traffic collision detection in conjunction with SkyDemon, but the algorithms in SkyDemon for that are much more aimed at GA airplanes who want to know if somebody's a mile or two away, rather than gliders, where we're much more fine-tuned about when we want an alarm. Cost is about 500 quid, and a couple of big buts. The first one is it doesn't integrate in any way with gliding avionics for two reasons. One is the protocol it outputs on is different from the protocol that gliding avionics use, and secondly, because of the collision, where the collision detection happens. And also it won't currently be seen by air traffic control, with one or two exceptions, which I'll come to. Okay, so what do the regulations say? Right, so I've got a caveat on this, which is a little knowledge is dangerous, and the regulations are not my strong suit, but in principle, changes to EASA aircraft and whatever we call them these days, Part 21 aircraft, require approval, at least a minor mod. So in theory, at any rate, sticking anything into a glider requires a minor mod. I have to say, I think we more or less ignore that rule. in the gliding world. But EASA with something called CS Stan have been making that easier. So installation of antennas, installation of Flam, traffic awareness beacon systems, and so on, sailplane equipment, they're not very worried about. They let us do it. So putting these things in gliders is not really a big issue. Flam and Pilot Aware are not certified as avionics, but they do meet the regulations for ISM-bound products. They're consumer regulations, not avionics regulations. The Adsb products, such as the Sky Echo 2, do meet the Adsb certified regulations. So they have a better chance of interworking with commercial air traffic and air traffic control systems. And if you look at what the CAA are proposing to do for example, in getting bits of airspace that might be used by drones, they are thinking quite hard about using Adsb systems in there. They're not really doing it, not really considering using Pilot Aware or Flam, which is a shame. Politics, interesting one, this. The politics are pretty complex. Flam are pretty defensive about their market. They do license technologies to others, but they're a relatively high-cost provider, as we know, and they've been quite aggressive when they felt other people are stepping on their toes. So there was a competitor who tried a number of years ago, who tried to come in and make things that interworked with Flam. And that's the point at which they started encrypting their signals and basically drove them out of the market. Pilot Aware are being pretty cautious about not stepping on Flam's toes. And for that reason, they haven't put any collision detection, significant collision detection in their product. UAvionics are developing some weather services and doing some work with Flam. Pilot Aware and UAvionics don't get on well together at all, although both are talking to EASA, and the BGA are being pretty studiously neutral about the whole thing, which is probably wise. The CAA, on the other hand, have come down reasonably hard in favor of Adsb, but not so hard as to mandate it. So Adsb in and out using 1090 megahertz is the preferred national system, and ideally through transponders. That was a 2017 statement, and I don't think they've done much different to that recently. On the other hand, the current Secretary of State in the Department of Transport is quite keen on other things, so there's some conflicts there. They have run some trials a bit with air traffic control, outside controlled airspace, but only using Adsb and multilateration for traffic information. Some weather data trials, so that's passing weather data up the secondary frequency. They had a bit of an issue with simultaneously doing mode airsand, low-powered Adsb transponder transmissions, which they've overcome. And they're now looking a bit more at real-time traffic data to GA airfields. So there's stuff happening there. There are, though, no current plans to use Adsb for general air traffic control, and EASA don't appear to be mandating it either. But there are also some technology concerns floating around, particularly about the Adsb bandwidth. So as I said earlier, this is a somewhat old technology, and if they were to mandate it so that everybody had to fly using it, the interesting question is what happens if we launch 2 competitions out of Lasham, say, and we've got 100 gliders milling around in a few square miles underneath London's TMA. Are they still going to be able to see the commercial air traffic in there, or is it going to get blocked out? And the studies that have been done on that are not particularly compelling in as much as we've seen them. Okay, let's have a quick pause and see if we've got any questions that we want to answer.
So we've had a couple of questions about pilot aware from Julian and Steve.
Okay.
So Julian Hitchcock asks, is there a time delay on pilot aware retransmits?
It's pretty short, actually, Julian. So initially, if you look at the Open Glider network, there is a fairly significant time delay between the transmission from the glider and that transmission getting through the various servers in order to and showing on your web page. So what the PilotAware guys did is they put their own network in, and the OGNR stations are networked directly to a server, and the information rebroadcast, and the time delay is down to pretty much insignificance. I'm not sure you'd want to use it in terms of anti-collision if you were in the same thermal as somebody. I don't think it's designed for that. But in terms of somebody who might be in your vicinity and getting close, the time delay is not an issue. How do you resolve the battery issues? I presume you mean by having this equipment in a glider. In my glider, I have one instrument battery, which is a LiFePO 3, LiFePO 4, whatever, battery. The instrument battery is 14 amp hours, I think, and it will support an LX9070, a PilotAware, a transponder, and a radio, and another display for more than 6 hours. I don't think there are any significant battery issues. Battery issues have got better, and this is not a big deal. Okay, John says BGA is clear. Installation of Flam can be done on owner-operator rules. Yeah, I think I've never heard anybody complaining of that. Flam might say differently, but I think I agree with you, John. Are gliding software developers likely to adapt their products to work with Sky Echo 2? Really good question. I haven't heard of that. So the big deal is on this is it's not just the protocol difference, which would be easy to solve. It's where you put the collision detection stuff. So I guess maybe is the answer, but I haven't heard of that. Somebody's done something for LK8000, I think, with at least as a trial to get the protocol from Sky Echo 2 in, but it won't solve the detection problem. Okay, Ray says, I understand I need to put an aircraft identifier in my PilotAware or SE2, but what if I want to take the device with me between different aircraft? Is there a way of putting in a more general identifier that will make this straightforward when swapping between gliders? I think, Ray, it depends on whether you've got something else emitting something. If you've got, for example, a transponder in the glider, you want to make the two identifiers line up. So you would change the identifier when you move the Sky Echo, but that's easy to do as it happens. Okay, Keith says, I live and often fly near RAF Waddington, which is about to start Protector RPAS trials, but without certified status to operate in mixed traffic environments. As a result, they're imposing large areas of restricted airspace for the trials. What technology are they hoping to use them to allow them to mix with other traffic? Keith, I'm not sure, but I do know that as I mentioned earlier, I think there is a chance that the CAA will make use of people and will allow people emitting Adsb into such things, less likely that unfortunately, that they will use Flam or PilotAware. Okay. JB says the CAA information doesn't seem very clear about what the disadvantages are of using non-certified GPS for Adsb versus a certified GPS source in terms of the significance of who may not see you. No, you're probably right. I think, to be honest, for the sort of airspace that we fly in, it doesn't make much difference. Tim Freegard might have a view on this because we've been discussing this on email. But in order to be seen by certified aircraft, the levels of system integrity that you need are quite high, and most GA output Adsb doesn't achieve that. But on the other hand, we're not generally flying in airspace with those things in it. A transponder probably can protect you better. Okay, let's move on. Right, so meanwhile, new products are selling fast and the market is making its own mind up. Well, the market is still pretty confused, actually. Pilotware's done quite well. At a price point of 325 quid, it's fairly much an impulse purchase for people who fly around in expensive powered airplanes. And as of 2019, they had about 15 to 20% penetration of GA, I think, on my numbers. It's also the lowest cost means of getting Adsb in currently. UAvionics, 500 quid, not bad. More recent than Pilotware. As of 2019, when I first wrote this slide, the sales that I estimated were rather lower, but they've been doing pretty well recently, and particularly with the CAA behind them, I suspect they've outsold Pilotware. But we'll have a look at that in a moment. The BGA has a position on this. So our view is that any electronic conspicuity system should improve and should not jeopardize our safety. So we want things to work together, basically, and we want to make airspace accessible, and we want to be able to do it without draining our batteries and at modest cost. These are great ambitions. They're difficult to achieve, and not result in distraction, target fixation, or complacency in the glider or GA cockpit. We've got some ways of doing that. So we want some demonstrated accurate collision warnings, a low rate of false negatives, avoid warnings in non-threatened situations. I think these are things that Flam are quite good at. Have low power consumption, be able to be permanently installed in the airplanes that we fly, and be compatible with glider airframes. So these are good targets, but they're difficult to achieve. This one about false negatives is pretty important. I've talked about collision detection and traffic detection. One of the things that Pilotware has out of the box is it does make some attempt, which I haven't mentioned before, some attempt to tell you about traffic. So it's traffic awareness. And if you connect it up to a loudspeaker or through your radio, it will say things like traffic 10 o'clock 1 mile or traffic 10 o'clock 3 miles when it detects stuff. And the first time I put it in, I connected that up. I flew down in the Alps, and it lasted one flight because all that happened was the thing constantly jabbered about traffic. There was too much traffic, and the signal to noise ratio of the warnings was way too low. So that feature we have in Flam, where it's quite specific, is useful for us. This is a problem. The authorities are being very slow to make use of electronic conspicuity location data for air traffic control purposes. And the reason this is tricky is, so if you go past an airfield so Cranfield, let me take Cranfield as an example. I fly past Cranfield pretty frequently. They don't have a radar. And if I call them and tell them I'm, say, 3 miles south of Bedford and heading west, that's the only thing they know. If I do it in a powered airplane, they've got a mental model of where I might be because they know roughly how fast I'm going, they know what direction I'm going, and they know what height I am. If I do it in a glider, they have no clue. How can they? They don't know within 30 degrees which direction I'm going to end up going in. I might stop and climb. Who knows? But they will try and pass that information on to another pilot who calls up, who might be doing an instrument approach or something at Cranfield. But what they won't do is look on their iPad and see where I actually am and pass that information on. And the reason they won't do that is they're not allowed to by the CAA. There are a few RAF units who aren't controlled by the CAA who are beginning to look at doing that and making use of that information. And I think a number of people in the gliding world think that air traffic controllers using that information could actually significantly reduce collision risk, and we need to press harder to have them do that. They did a little bit of, so AOPA ran some trials using electronic conspicuity for general aviation air traffic units, and that's good. So it was giving controllers situational awareness, but it was only using Adsb, and they ran it for 6 months at 3 places. I know that Cranfield are going to be putting something similar in, but they still have the issue of whether their controllers are allowed to see it and make any use of the information. And here's the issue. So these blue bars are my estimates from 2019. My estimates of the sales of transponders, the installed fleet in the UK of transponders, pilot aware, Flam, and Adsb. And I've put some pretty big error bars on them, which are the orange bits. Since then, I think pilot aware have grown, and I think the general aviation Adsb has grown quite significantly, but I've no real idea of how much. But you can see if the only thing, even so, if the only thing you're looking at in terms of providing air traffic controllers with information is the Adsb part of that, you're missing most of the picture. And the crazy thing is we can give them all that information right now. Okay, where's it all going? Surely we just want one system. We've got all these systems I've described to you. Why don't we just have one? Well, the answer is they're providing different things. So on the one hand, we've got certification and assurance, we've got functionality, and we've got cost. And the different systems do those 3 things in different ways. And cost is a huge driver of take-up, as has been demonstrated by the pilot aware relative success. So the certified world need a different set of things from the GA world, from the gliding world, and that's why we have different systems. Be wary of the hype, though. Just because somebody says they've got an electronic conspicuity system, and if you don't think that if you stick it in your glider, you will see everything that it might possibly see. This picture is some actual data of, I think, probably Flam, looking at these numbers. And this is, on the horizontal axis is time, the vertical axis is the distance away from me, and the different colors are different contacts. So you can see, if you look at this from the starting at the left, we've got an orange contact there that gets to about 1,300 meters away from me and then disappears from view until a couple of minutes later when it reappears again at about 1,700 meters. So what happened during that time? Well, somewhere between the 2 sets of antennas, it blanked out. And all of these traces have big gaps in them. So this applies to pretty much all the systems that we've been discussing. The placement of antennas in particular is really important. So will Adsb be the ubiquitous solution or not? I don't know. Take-up may improve if price reduces. It is doing reasonably well. Pilot aware might actually help because it does detect Adsb. So the more pilot awares are out there, the more it's useful to somebody to have Adsb. And it's providing some price and big-time innovation competition. We get a lot of drones around doing Adsb. It could be an issue. But I think it's going to take quite a lot of time. And there are some unresolved technical questions. So what might happen is a second frequency for GA in the same way that they do that in the US. And I mentioned that earlier. I think there are actually some moves that are happening right now on that. Okay, so the big question, what are we as a glider pilot? What should we do? Well, it's complicated. Which products, which protocols? Do we want traffic awareness, collision detection, collision avoidance? Where do we do the alerting? And how do we integrate with existing glider nav systems? So the first thing I think we should do is put Flam in. Flam remains the choice for primary electronic conspicuity and anti-collision for gliding, and will do so for quite a long term. The reason for that, I said right up front, gliders are the main threat to us. Most of the big risk of collision for us is gliders. And we get the traffic alerting functionality. And remember, the dangerous place is near the gliding club, in the circuit, local soaring. And that's when you want your eyes out. You don't want to be staring at a screen trying to see if there's any traffic. So you need something that is going to alert you if somebody's going to hit you. It works with gliding avionics, and it's got pretty high penetration cross-country, certainly with cross-country gliders. You can add functionality to it, so you can get detection of transponders. This is what's called bearingless detection, or Adsb in, but it's relatively expensive. Base costs around 800 quid, maybe up to 1450, 1500 pounds for something with a bit more functionality. You'll hear two different words used, Flam and Power Flam. They're essentially the same thing. Power Flam, as its name suggests, emits a bit more power, not a lot, 5 times as much, something like that, which doesn't make much difference actually, but also has a somewhat more sensitive radio. I don't know that you can buy anything other than Power Flam at the moment, but that's what you'd want to buy, a Power Flam. But if you're going to put Flam in, it is the thing to put in. If you're going to put it in, it's somewhere around those costs. Then you have to decide whether you want air traffic control to see you. And if you want air traffic control to see you, a transponder is what you need. It makes crossings of controlled airspace and matches much easier. It will keep big heavy stuff that flies around in Class G away from you, because they'll be getting a traffic service and they will be able to see you. The exceptions are, there are some military air traffic units using OGN to see Flam. I'm not sure how much control they're doing with it. And I've mentioned this trial. For some people, adding Adsb out should be pretty easy. So if you can, absolutely do it. You can do it if you've got, for example, a trig transponder that is enabled for that, and the trig will upgrade the software at no cost if yours isn't already. Either you can just connect it straight to an uncertified GPS like your LX, or they do a certified GPS, something called a TNS 72, which is about 375 quid. I think on the whole, I've just bought one, but really only to play. But on the whole, I wouldn't bother. Or you could buy a Sky Echo as an Adsb out solution. So that would give you Adsb out, but it costs about 500 quid. And then after that, to detect Adsb, you've got a range of solutions. You could use a Sky Echo but you'd need a separate display. Not great. A Power Flam with Adsb in it, that would be the preferred choice, but again, the most expensive. That's because that would give you collision detection. There's a little Garrett device, the TRX 1090, which I think also gives you collision detection, but I'm not sure. Or you could use one of the Pilot Awares, but probably worth waiting for the FX, which would integrate much more easily, but you don't get the collision detection. So that's what this is. The pilot wear can work with gliding systems, but it's not, and it's definitely not suitable for primary electronic collision for gliding. Actually, the FX will overcome most of these problems. Yeah. Okay, so let's just summarize. See and avoid isn't very good at seeing and avoiding. Electronic conspicuity can help. There's a whole bunch of technologies we can choose between. Flam remains the primary choice for anti-collision with a transponder for air traffic control visibility, but we can add Adsb and or pilot aware. And it would be really nice if the authorities did more to reduce collision risk by making use of the signals we're already transmitting. So that's my bit. We've got a chance to do some questions. Let's see what we've got. Keith says there must be significant latency issues associated with the involvement of the internet. A few seconds can make a big difference. Will this ever be resolved? Yeah, the network I was describing that Pilot Aware are using is pretty fast. Again, as I said earlier, I think I'm not sure it would be fast enough to be useful in a thermal, but in terms of somebody coming from away towards you, it's good enough. Andrew McCrory says, if we have to change electronic conspicuity systems, having made big efforts to adopt Flam, is there any mention of financial grants? No, not what I've heard. I don't think there's any suggestion that, I think one could imagine in the future sometime, companies doing products that used Adsb that might work with gliders. I suspect what will actually happen is what we'll see is people like LX and Navitor and people like that doing products that will do Adsb out and Flam. The issue is really how you get the functionality of Flam at the same time as the functionality of the Adsb. In a way that gliders can use. So I can't see Flam going away anytime in the next 5 to 10 years. So that's a long time for people to think about financial grants. Okay. Luke, have we got anything else that... Alan Swan says, is it worth mentioning how Flam works with regard to track, not heading? That is high wind on ridges. Yes, that's probably worth mentioning. So we talked a little bit about how Flam gives you the direction of a contact. What you have to realize is that direction is associated with your track. And if your track is significantly different from your heading, you need to take that into account. So that might be the case on a ridge, for example, where with opposite direction traffic, both of you are pointing into wind somewhat, or if you were in wave, when your track can be very, very different from your heading. But so yes, there's an interesting, I think, question about if you get a Flam alert, what should you do first? Should you look out or should you look at the Flam display? I try to get the Flam display on my way as my eyes move around the cockpit, which is why I like the little display right up on top of the coaming, so I can see it. On the whole, if you look in the right direction, you'll see the contact earlier. If you look in the wrong direction, you'll see it later. So good question. Julian points out that Flam is great fitted in tugs. Absolutely, agree 100%. Okay. What else we got? Should there be a campaign of writing to MPs to ask the CAA why they weren't increasing aviation safety? Good question. I think the issue for them is there is a trade-off between certification of devices and ubiquity, if you like. What the view they generally take is they need to be absolutely sure of something, and they can't be absolutely sure of Flam. so they won't use it. Now, whether that's the right trade-off or not is a very interesting question. Okay, is there anything else?
We just had a couple more.
Okay. Right, John Klunder, does enabling transponder ADSB out with non-certified GPS source, i.e. still equals 0, have any potential advantages for us? Granted, the heavies and ATC will not see it, but possibly GA and drones might. Together with the power Flam having ADSB in, that might be useful. Yes, absolutely. I think you've answered your own question. The reason I was equivocal about whether it was worth putting a certified GPS, paying extra money to put a certified GPS source in, is I think most of the threats to us are first other gliders, second GA aeroplanes who might be carrying a Sky Echo or a Pilot Aware as their ADSB in, and they will see us. So the things that won't see us are the big heavy stuff with the certified ADSB kit. If you've got a transponder putting your ADSB out, they'll see the transponder. But if you've just got a different system, so actually to your question, they will see us because of the transponder, not because of the ADSB. But if you were carrying a Sky Echo or something as your ADSB out, then the big heavy stuff won't see us. But the chance of getting hit by one of those is very low. So not very worried. Okay. Oh yes, I didn't mention the CAA. CAA are giving 250 quid, up to half the cost, up to 250 quid for somebody that buys a piece of electronic conspicuity equipment. So that could be a Flam, it could be a Sky Echo, it could be a Pilot Aware, it could be the certified GPS. Okay, Julian says, Goodwood have applied for TDA for 5-month BVLOS trials this summer. Any advice? So my understanding of what they're going to be doing there is they're going to be using some of UAvionics' kit. And this is where what I was saying about the CAA making use of ADSB to allow people into such pieces of airspace. So BVLOS is beyond visual line of sight for drones. So I suspect what will happen there is if you are emitting ADSB, you might be able to get into the airspace, but if you're emitting Flam or Pilot Aware, you won't be able to. That's where we are. Okay, somebody says, I've got Power Flam core with ADSB in. Should the next step be a transponder on my shopping list? Yeah, probably. It depends on what you want. If you want the transponder, the primary use for a transponder for a glider, as I said earlier, was to get reasonably easy access to airspace. It is a whole lot easier to get a clearance through a piece of Class D if you've got a transponder than if it isn't, if you don't have a transponder. Alan Swan says, can you use a Sky Echo 2 to enter a TMZ like Bryce Norton? No. No, you can't. It would be nice if you could, but they haven't got there yet. Tim Frigard, thanks, Tim. CA have assured us that the rebate also applies to upgrades. Good. Can you show that one, Luke? Thanks. Yeah. In principle, you just need a receipt within the period, but the process will also ask for a serial number. Tim, do you know what the cutoff date on that scheme is? David Innes points out that you need a transponder for flights above flight level 100, except in limited areas. Yes, absolutely true. Thanks, Tim. End of March, he says, for the cutoff for that scheme. Yeah, I think the CAO have been pretty good on this this scheme. Pretty much, they've accepted, as far as I can work out, pretty much anything to do with electronic conspicuity. I used it for TNS 72, but Flam, and pretty much anything will get it. Power Flam upgrade, all that stuff.